So next thing we're up to is algebraic fractions. The key, of course, is always factorise first. So the first thing you do whenever you're dealing with algebraic fractions is factorise. Okay. Now, the other golden rule, and again I didn't know how to put this into words, so I used the symbols. You only cancel complete parentheses, not bits of them. You know? People love cancelling. Oh, x and 2 and 2. It's got to be a complete set of parentheses, and that's why we factorise first, so we can get all those factors multiplied together and we know what to cancel. Well, here's one, of course, that a very simple one that we start off with, where it's just a single fraction, but you're looking for things that are in top and bottom, and you go, oh, look at that. Hang on. 16, 24, well, that's 2/3, the a goes into the a cubed, and so on. So probably the simplest type of algebraic fraction question that you started seeing way back in whenever it was you first did algebra. And then we got to ones like this. Now this is where we've got to factorise first. This particular fraction, in a topic we do later on in the year, actually will become quite familiar. So anyway, let's factorise it. On the top we have a common factor of a. On the bottom there's a common factor of 2a, but then you go, oh, hang on a sec. P squared minus q squared, that can factorise as well. So we've got p minus q, p plus q. Now we can look at it and go, oh yeah, look, top and bottom. There's a p minus q, we can cancel that. There's an a that'll cancel as well. And we just get p plus q on 2. So, man, that's the idea. Then when we multiply, this is where we start going crazy, because you can cancel anything in the numerator with the denominator, and it doesn't even have to be in the same fraction, so we can cross things out to our heart's content. But of course, before I do that, I've got to do something. What have I got to do? Oh good, someone's listening. Factorise, always factorise first. What would you factorise first there? Right? That's what I'd factorise first, because that's all you can do with it. Like, I can't factorise x plus 1, so I'll just bung some parentheses around them. And the same with the 3x plus 1. Now, what do you reckon I did? The difference of two squares, or did I do the trinomial? God, you've got a 50-50 chance here. Someone be brave. You reckon difference of two squares? Yes, indeed. Yeah, I agree. I would have gone, that's usually the easier one. Then you've got the quadratic trinomial. You might want to do some working to the side to work that one out. Sometimes you can't immediately see it. Mind you, when the number's 1, it makes life a bit easier, because prime numbers, well, of course 1's not a prime number, but yeah, you can, there's only one way. 1 times 1 is 1. I mean, that's all you can do. That one ends up being 3x minus 1, x plus 1. Mind you, you can also cheat. Oh no, don't cheat. Never cheat. Or fudge. But it's sort of kind of logical when you look at the other factors and you know things are going to cancel. There's a really strong chance, after I've done all that this factor is going to be, well, 3x minus 1 would cancel with the 3x minus 1 and the x plus 1. If you're going to sort of use that cheating method, I would double check and make sure it is the correct one, because there's nothing to say it is going to. But in this case, they do all cancel, and we're just left with 1. Everything cancels down to 1. Okay, division. The difference with division. What do we do first with division? Anyone? Oh, we're still not brave, are we? Just flip it? No, factorise. Always factorise first. All right. Mind you, you are right. And I usually do that in one step. I flip it and factorise in the same one. So let's flip it. The 3a, well, there's nothing we can do with that. The 6a squared b. Then we've got, common factor of b over there. And we actually have a perfect square. So we now have b's cancelling. We've got an a with the a squared, an a minus 2b, and there we go. We end up with 1 on 2a, a minus 2b. Subtraction. Fractions. When we're subtracting, this one is a little bit different, because before we can add and subtract, with fractions, what have we got to do? What's the first thing we've got to do? Anyone? Oh, I would have thought it was becoming obvious by now. Factorise, good. Always factorise first. Okay. So there we go. I've factorised that one. Because, of course, when we're dealing with fractions, we have to get a common denominator. But before we can work out what the common denominator is, we have to factorise it. So we always factorise first. Now, how I handle these ones, I draw in my vinculum, as we learnt yesterday, that's what the fraction bar is called, the vinculum. And then I create my denominator. And the way I create the denominator is I simply say, if it's not there, put it down. So I work from left to right. A, well, obviously nothing's there yet, so yes, I'll put it down. A minus 1, I'll put it down. A, oh, it's already there, I don't need it again. A plus 1, I'll put it down. That becomes my denominator. So if it's not there, put it down. Then to work out the numerator, I say, what's different? So I just compare. So I look at this fraction, I go, well look, it was a minus 1. What's different? The difference is I now have another factor of a plus 1, so that's what I'll do to the top. I'll increase it, because there's already an a plus 1 there, but it will now be a plus 1 squared. And then I'll do that with the second one, minus what's different in this one. This time I've got an additional factor of a minus 1, so it'll be my minus a minus 1 squared. So I just compare and go, okay, what's different? Now, to get to the next step, I've got to factorise. Because again, notice, as soon as I put a minus there, now I've got two terms. Before I do anything, I factorise. However, you can use patterns of maths to save time, because if you look at what we've actually got here, I've got a perfect square minus a perfect square. Now, if I get a perfect square and I subtract a perfect square, what's going to happen? The a squared and the b squared is going to cancel, and I'm going to be left with that middle term. One's going to be 2ab, and then I'll go minus. I'll end up with 4 times the product. So if you look at those sort of patterns, you can get to the answer straight away. Otherwise, hey, there's nothing wrong with expanding the whole thing out. But sure enough, you end up with 4 times the product. Okay? But if you let the patterns work for you, then the maths can become quicker. Yes, we've still got some cancelling. The a cancels and we get our final answer. 3 fractions this time. Already factorised most of it. There's the x squared minus y squared still needs doing. So let's do that. Let's create our denominator. So I work from left to right. X plus y squared, put it down. X minus y squared, put it down. X plus y. Well, there's an x plus y squared there. Whenever you're working out what goes in there, the highest power must be there. So in this case, squared is the higher power, so that's what needs to be in the denominator. X minus y squared, okay. Now let's compare. What's different? First fraction, there's this additional factor of x minus y squared. Plus, second fraction, additional factor, x plus y all squared. Minus, well, I've got x plus y, x minus y, but I need that factor again to make it squared. So it'll be minus 2 lots of course, x plus y, x minus y. Now this becomes fun if you're trying to look at the pattern, but again, if you're unsure, we'll just expand the whole thing out. But if you look at the pattern, I've got a perfect square, this time plus a perfect square. So this time the middle terms should cancel. The minus 2ab and the 2ab will cancel. So I'm going to have twice the x squared and twice the y squared, but I'm now going to subtract twice the difference of 2 squares. So I'm then from that going to take away 2x squared minus, which is plus 2y squared. What am I now left with? I think the x squareds have gone, have they? And I'm now left with just the y squared. I think it's 4y squared. Let's see. Expand the whole thing out. Yeah, so we're left with the 4y squared. Remember, the more you try to do in one step, the greater the chance of making a silly mistake. I could have easily made a silly mistake there as I was thinking through that. If you find yourself making silly mistake, then all that means is, hey, just use another line. Don't try and do so much in one go. Take an extra step. Make sure of it. Okay, so exercise 1D.